So this lesson is on mask. The keyword is adaptive. So in regression, adaptives means that depends on the data that I draw the line based on that particular range of data. So let's look at one example. The example is the economics data. Okay. So this is the economics data. So now if you look at this data, if you just draw one best fit line, it don't make sense, right? So you probably want to have a bit of spline, like for example here and here. So like a V shape, because it's a V shape data, right? So for this range of X, you're going to draw a line like this. For this range of X, you're going to draw another line like this. So if you look at this is a linear regression model. So this is this straight line model. So but if you draw just one straight line like this, then the error is quite huge if you look at this, right? So that is no good. So we should try to uh, draw like a V shape V line. Huh? So this is, if you look at the blue line, so this is a better fit than the straight line because the shape of the data, right? So of course the function is called earth. It's actually mass. So this the function is earth. So this is how the formula is represented. So this is the point that the gross net this productivity. So minus this 365,385, which is this point. Okay. So you have two different line inside this formula. So mass 1 you have 0.00552. So if you look at the uh, if you look at more other factors, okay, so the RMSE will be 0.13 or 0.0013. So which is lower than the with the multiple factors. Okay, of course lower than the single factors, right? So this one is the mass on this unemployed and employed. So this is the mass 2, 0.0125, the RMSE. So mass perform slightly better. So if you look at model 1 mass, so 0.006 can change to, can drop to 0.005. And for model 2, 0.001, because you're using multiple factors, right? So the mass can drop slightly by 0.005, which is quite, in terms of percentage, is easily 10% of improvement. So let's see how we run the program on mass. This is the mass. So, okay. So if you look at the mass itself, when you run the code, so they are all together M1 masked, right? And M2 masked. So this is the M1. So this is the data for unemployment rates. Okay, and this is the RMSE for model 1. So model 1 we are only using GMP. So that's our error 0.006. Then we have our model 1. Then this is the mass 1. So by right, it should have better results than the M1. So if you look at these two, so it's slightly better on the right side now. So now we have to plot this M1. So this is the two lines. So M2, same thing. Now we have quite a lot of parameter, except we take all the, of course, unemployed, this data, right? Not supposed to be in. And so this is the one that we have M2. We have looking at more variable at the same time. And M2 we have 0.001 because we are looking at multiple factors, right? Then we can have lesser error. That's the M2. So let's look at the mass for M2. So mass for M2 should drop, okay, should improve. So 0.001. So you can see 0.013 versus 0.0012. So there's slight improvement. So of course, it's difficult to plot for multiple factors, okay, and this will end the mask. In conclusion, the mask can perform better than the normal, just a single straight line. Thank you for listening.